Welcome to this video lecture on multivariate analysis. We begin with principal components analysis. Principal components analysis takes a set of data where there are many variables and replaces that large number of variables with a small number of variables, while still retaining a lot of the information in the original data set. It does this by producing linear combinations of the original variables. One advantage of the new set of variables is that they are uncorrelated with each other, and this makes them more useful, for example, for constructing a regression model, because the problems of multicollinearity will not arise. But the smaller number of variables produced by these principal components can be useful. Indeed, they may have intuitive meanings. They may or may not have intuitive meanings. We'll look at an example shortly. But they do tend to be more useful for analysis and for prediction. The example we look at here consists of the first two principal components from a set of data consisting of measurements made on hurling players. So when we extract the principal components, the first component and the second component are shown in the horizontal and vertical axis of this loading plot. The first component, we could say, roughly corresponds to the strength of the athlete. It's got things like height and grip and weight. So size and strength, roughly speaking, would describe what that first component seems to reflect. While the second component, the variables that you see in the vertical direction corresponding to the second component, have to do with fitness or agility. How long it takes the athlete to run 5, 10 or 20 meters from a standing position, and the jump, the CMJ, a jump measurement. So strength and agility might be useful descriptors for what these first and second components represent. But whether or not we can supply intuitive meanings, the components can be useful. They give us a smaller number of variables, but which still retain a lot of the information in the original data set. Factor analysis is somewhat similar to principal components analysis, but factor analysis uses the underlying factors to explain the observed data, whereas principal components begins with the data itself. It uses the data itself. But factor analysis expresses the observed variables as combinations of the underlying factors. The next multivariate technique we'll consider is discriminant analysis. Now, we have already in binary logistic regression, we have considered discriminating between borrowers who may or may not default on their credit card loans. And in that case, there were only two categories: default, yes, or default, no. Discriminant analysis does a similar task, but can do so when there are more than two categories. So discriminant analysis uses a number of variables to classify observations into a number of predicted groups. And the groups must be known in advance. And this will help to explain the relationship between the variables and the groups. And it can be useful then for suggesting classifications for new observations that come along. But its advantage over binary logistic regression is that while it does a similar task, it can be used with more than two categories. Here's an example of discriminant analysis used to classify hurling players into their four different positions: defender, forward, goalkeeper, and midfield, based on measurements made on the athletes themselves. And this discriminant analysis has done quite a good job in that we see out of the 16 defenders, 15 were put into the correct group using this approach. And so on for the other categories. The success rate was quite high. We then take a new athlete and we perform all the measurements on that athlete of height and weight and so on, and we predict which group they would belong to. And for this athlete, they are allocated to forwards. The probability of their forward is 0.999, very high indeed. So with high degree of certainty, we can say this new athlete who has perhaps just taken up this sport and is interested to know what position they should play, we can advise this player that they are a good fit for a forward position. Cluster analysis is another multivariate technique. Cluster analysis is used to divide a set of observations or variables into groups when there are no prior groups that are known. So there are no previous group classifications are provided. We just have a large data set and all these observations, and we would like to separate these observations into a number of clusters. An example here shows how this is done with a data set consisting of observations made on individuals applying for credit cards. So the credit card scorecard variables, we're going to divide those into groups. So we see here there are 8 variables as listed on the horizontal axis. And this dendrogram shows how these variables can be divided into 2 groups, or 3 groups, or 4 groups. So starting at the right-hand side, if they're divided into 2 groups, those 2 variables on the extreme right form one group, and all the other variables go into a different group. And those 2 variables are months at address and convictions, both of which have to do with the applicant's history. So you can say the variables are divided into 2 groups. One group to do with the applicant's history, and another group to deal with everything else. If we then proceed to divide into 3 groups, in addition to the applicant's history, coming across the graph from right to left, we see another group is the loan to value ratio and the installment to income ratio, which has to do with the ease of repayment of the loan. So we've got the applicant's history, the ease of repayment of the loan, and then everything else about the applicant. If we go to 4 groups, we've got the applicant's history on the right, then the ease of repayment of the loan, then we've got the age and months in job, which has to do with the personal profile of the applicant. And then over on the left of the graph, the income and months with bank, which is the financial profile of the applicant. So we can see here how we can divide a set of variables or observations into clusters or groups that may be useful to put these things together into groups. You can read more about this in the textbook.